Hello students, very good morning to all of you. Welcome to today's online video lecture series of Artificial Intelligence and Intelligence System for BTech Computer Science and BCA students, provided by St. Andrews Institute of Technology and Management, affiliated to Maharishi Dayananda University, Rohtak, approved by Government of India, AICTE. I am Ms. Ritishri Patnaik, working as Assistant Professor in the Department of Computer Science. In today's lecture, we are going to start with a new topic, that is fuzzy logic, and how this topic is important to make a study in the field of artificial intelligence or the intelligence system. What is fuzzy logic, how it is going to be differ when we have a comparison study between the binary logic or the traditional logic in compare to the part of fuzzy logic. And mostly this fuzzy logic is important as for the students will face questions in the university examination, also in various competitive exam. So whenever we are come across with the term fuzzy, fuzzy in the sense where we are not having an exact meaning of fuzzy, something, the uncertainty where we come across, we are being resolving all those uncertainty with us. It is nothing else like the fuzzy logic is the superset of a Boolean logic, or like the traditional logic. In terms Boolean logic, when we say, we express every solution to a problem in two states only, whether it is yes or whether it is no, or else in the Boolean part we will consider every solution that will be for a problem statement will be in the form of zeros or 1. That is the conditional logic, or it is represented in the form of 0 and 1. So when we say the traditional logic is represented in the form of zeros and 1, so how these two states is going to be give you the value for the true case and the false case, and we will consider the fact that is relating between the 0 and 1. So let's begin with our class. Today we will focus with more part of the definition and all. So as we are talking about, the fuzzy logic is having a comparative study with the part of the Boolean logic also. In terms of traditional logic or the binary logic or the Boolean logic, we come across with the value that is going to be represented either in 0 or 1, or else the conditional block logic we come across with the value that has been decided by a human being, either it is true or either it is false. Okay, but whenever we are planning to represent something which is having a continuous set of values, it's not about a discrete value. Okay, when it is we are considering only a part of the discrete value, we will come across with either it is a true statement or a false statement. But when you have in a continuous state of solution for a problem, that time the conditional logic or the traditional logic or the binary logic, as we say, it fails to represent the part of the solution to the problem. So a scientist, the inventor of fuzzy logic, let's say Lotiva Zida, as you pronounce it, so he come across with this phenomena of the fuzzy logic, and he introduced in the field of artificial intelligence. Fuzzy logic is the method of reasoning that resembles human reasoning part. Okay, and the approach of fuzzy logic intimates with the good decision making system that involves all the intermediate possibles between the answer that is in between to the part of yes, yeah, no, in between to the condition statement that is lie between yes, yeah, no. The conditional statement we come across with two part only, that is either it is true or either it is false. But when we talk about a fuzzy logic, let's say we have an example in our mind. Suppose we are measuring the height of a human being. Okay, so for the universal measurement scale, we come across the calibration, as we say, that we come across a human being who is having a height of 6 feet, let's say. Okay, so it is considered as in a tall. Let's say the human being who is lies between a height of 5 foot, he come across with the average part, and below to the 5 foot we consider it low height. Okay, now when we say that a human being who will be approaching with a height of, let's say 7.1, where he is going to be considered, when we come across with 4.9 for a human being height, so at what category that human being is going to lie. Same way, when we have a condition with us that whether today I am going to eat my food or not. Okay, I am interested to have my food, that is a part. Whether I will take my food or not, that is in the range of yes or no. Yes, I am interested to eat my food. Yes, in traditional way, when we say, are you interested to have your food? Yes, I am interested to have You want to eat your food? No, I am not want to eat my food. That is a part that only lies between the two conditions, that is yes or no. But when we talk about the fuzzy logic, Lothivajadej, as he observed, like unlike human computers, the human being decision also include various of range of possibilities, where the yes and no also include many other conditions. Certainly yes, possibly yes, cannot say, possibly no, certainly no, because altogether whatever the rules that we are developing by using these all things, or the knowledge base that comes to the mind where we are implementing in the field of making an intelligent system, or making a robot system, or the agent that is in the part of intelligent system, clearly understood the query where it is going to be lie down between this particular possibility condition also existing. As we have come across with the part that fuzzy logic is also helped to gain more knowledge in the field and also represent the uncertainty cases, when sometimes we come across with several examples that are represent beyond our imagination or beyond the knowledge of the traditional logic. The fuzzy logic is going to helpful. For example, as I give you, I'll eat today. Yes, I'll eat today. This is the conditional about when I say in the field of traditional value. Okay, and later on in the part when I say that I'll eat later on, or possibly I'll going to eat, or possibly yes, I cannot say my answer, possibly no, certainly no. These are many different conclusory statements come to our mind where we come across with the implementation of fuzzy logic. Immediate, and also in the field of when we say in the field of fuzzy logic, we come across immediate transmission of certain agents intelligent system also the issue to develop. Sometimes, let's say, for example, we are been running the IoT mechanism, Internet of Things mechanism, in the field of automobile. Okay, and we allow the mechanism in a car. Let's say the speed of a car ultimately goes in a rapid way when we are approaching to a speed length of 90 km per hour. Automatically the car is going to give you a bip that the car is on a very rapid speed. The acceleration has to be minimized. Ultimately, when we have a remote sensing system in that, and we are also driving our car, ultimately the phone bips up, or the calling part, or somebody is making you call. So what? You will be stopping your car? No, not like, because Bluetooth mechanism and IoT has given you the previously many other concepts by through which we can develop a system, where also when we come down with the speed of a car that is very less to 20 km per hour, let's say the fuzzy system is going to help you to make down and give a message to you that the car acceleration need to be speed up. So these are various kind of application of fuzzy in the field of intelligent system. We'll go through with this lecture. We'll have a brief knowledge about what is fuzzy based system, how this fuzzy based system is also helpful in the part of creating a very good knowledge based system, how this fuzzy logic is also being giving a comparative study by developing the rule that is come under the part of inference system, and how the will come across with the crisp set and fuzzy set, how we are going to develop the member function of this fuzzy set, and lot on. So let's have how we are going to implement this. Fuzzy logic works is the level of possibility upon the input to achieve to the definite output. Implementation of fuzzy logic system is depend upon the various size and capability that is ranging from the microcontroller based work or network based workstation, or we are developing in the automobile industries, or we come across in the field of neural network, we come across in the field of artificial intelligence, we come across in the field of soft computing. So there are a lot of ways by which the fuzzy logic is being used. So why this fuzzy logic came into existence, why it is so required? Fuzzy logic is useful for the commercial purpose things. It is in a control mechanism. It is having a very good strong control mechanism, rather I'll say. It is mostly give you the accurate reasoning power, accurate like with also accepting the reasoning capability of human being or the uncertainty part. It going to helpful for that. It may not be too much accurate, but we will be accepting the reasoning part over here. Fuzzy logic helps to deal with the uncertainty in the part of engineering. Yeah, it's true. When the word uncertainty or the probabilistic uncertainty was the biggest issue in the field of we develop in the field of AI, but still the fuzzy is going to minimize the part of uncertainty. So what will be the architecture of the fuzzy logic? That is a part. We will be developing in a knowledge based system like a fuzzy logic system or fuzzy logic architecture in the build of an expert system. So how this is going to be helpful for us? It basically has the 4 parts. The architecture that we will be studying here, it consists of the 4 to 5 parts. Will come across with the fuzzification module. Will have a knowledge based system, inference engine, and defuzzification. These are the 4 modules, and every module has its own identity, own importance, how it is going to be work on. First of all, fuzzification, it informs the system to take the input in the crisp number into a fuzzy set. It splits into the signal into the 5 steps. See, crisp number is nothing. I mean, when we talk about the binary part or the binary logic way, this crisp number is same way the traditional set theory that we are using. Okay, for example, let's say fruit is a set. Okay, A belongs to the crisp set when we say crisp number also, or the fuzzy set when it will be converted to a fuzzy set will come across with the crisp set. So what happened when we say about a fruit? All the members that are belonging to that particular field, or like when we say all the elements that are belonging to that particular set, we have taken an overly set of fruits. So apple, mango, green, if I consider, these are all the crisp member of the fruit state. That is a part, and we are converting it into the part of fuzzy set. When I say it's an apple, it is having a fuzzy value. It is a green apple or it's a red apple, so it is a part. I'll giving one member function or the degree of a member function to each fruit. That is will be converted of a crisp set into a fuzzy set. So let's have when we say about the fuzzification module, it is going to have this 5 split into the 5 this major part, that is the when we talk about LP, X is the large positive. When we consider about in the field of positive and negative. Okay, so this positive and negative can be in the field of traditional, or like we'll say that conditional logic. But same thing when we consider about a fuzzification module, this positive and negative can have various ranges also. When we say X is positive, extra large positive, then we come across with empty, that is medium positive. When we have S is a small, X belonging to small, then this is minimum negative, this is large negative. So only the positive and negative we come across with 5 more states that is going to be exist in the field of fuzzification. What is knowledge base? Same way, the knowledge base is going to help you to provide you the expertise system, that all the rules are going to be the part of knowledge base that will store all the information by using the if then else tool. The inference engine, it stimulates the human reasoning process by making the fuzzy interference, okay, of the input and the if then rules. Then we have the part of defuzzification module. This defuzzification module will transform the fuzzy set obtained by the inference rule into the crisp value, because human being is going to study only the application of the crisp input only. Okay, so this is the system that we will be talking about. This is the architectural system. Okay, we have these all parts with us. We are providing the crisp input that may be medium or large or very positive. So these are the part. Okay, we are providing to the fuzzifier crisp input, only positive and negative is been provided. Now this fuzzifier, what it will do, it will break down this input into 5 different labels. Okay, and then it has been provided into the inference engine. This inference engine is same way stimulate about the human reasoning part, making the fuzzy interference by also inputting the rules that are present from the if then else tool. Okay, again it is going to for the defuzzifier. When defuzzifier will be there, it transform all the fuzzy input into the inference engine and provide you the crisp output to the function. The member function works with the variables that I used here. Now what is a member function in the fuzzifier? It follow users to quantify the linguistic term represented in the fuzzy state. Graphically, a member function, let's say set A is having the universal disclosure that is defined as mu A. Member function will be represented in the form of mu A, X belonging to 0, 1. That we have only 2 part as compared to the binary part. Binary logic, that 0 or 1 it is going to be whether it is inputted, and the part of 0, 1 that is the value. Here each example of X is going to be mapped between 0 and 1. It is the member function or the degree of a membership that we provide. Okay, some book it has been given that this is a degree of membership, and in some book it is mentioned a membership value. So we have 2 coordinates with us, X and Y, and all the membership are going to be lied down with this value. That is the part of when we talk about LP, that is the part as we come across with this table, large positive when we say about the medium positive, when we say about the small, when we say about the minimum negative or the medium negative, and this is the lowest negative. So this member function is going to helpful for us. We will be making this conversation in between 0 and 1, 0 to 1 के ऊपर ये lie कर रहा है, and we will be providing the voltage to this signal that is from -10 to +10. Okay, we are making a barrier or a wall at a condition member function. When 0, it is going to be small, or x is completely going to be 0 value. This is going to give you the multiple membership value, the fuzzy of a numerical value chart. Simple member function are used with a complex set, doesn't require more precisely. The triangle membership shapes are been the most part where we are coming across with this value, that when we say this the value that is lies between membership function and the input voltage, when we are providing a membership function 0 and the input voltage is lies between -10 to 10, this is going to be represented in the left hand side. And when we are providing the value that is going between membership value 0 to 1 and having the input voltage that is between 0 to +10 onwards, that is this is going to be on the right hand, that is provided by the maximum positive or the median positive or the lowest positive case. The triangular memberships are mostly common example where the membership shapes are in the trapezoidal, singleton and the Gaussian case. These are the member functions. Mostly this Gaussian function and derivation will be studied in the field of neural network. In the above example, we are using a 5 label fuzzifier which is varies from -10 volt to +10 volt. Hence, the corresponding output values can be changed on. Now, what will be the example of fuzzy logic system? Let's consider the fuzzy logic system will be studied more better. Within we'll be taking an example of air conditioner by comparing the room temperature and the target value of the temperature. So, this is the diagram of a fuzzifier or the fuzzy based system air conditioner that we'll be studying. So, we come across with a room, we have a air conditioner or AC that is been given. The value is going to be depend upon the target temperature, and this fuzzy logic system we are implementing it. Now, what will be the room temperature and how the target temperature is going to be evaluated? Most commonly we come across with 3 factors, that is heat, cool and no change, that is the condition, and this room air condition is going to be work on with the implementation of fuzzy logic system. So, how this system can be developed? So, we will be developing an algorithm for this. Define the linguistic variable in the term of start chart, where it is going to start on. Construct a membership function to them. Construct a good knowledge based rule system. Convert the crisp data into fuzzy state using the member function, that is the fuzzification, as we studied in the architecture also. This is going to be the role of fuzzification. Evaluate the rules in the rule based system by using the inference rule, if then else, whatever the rules that are used, and or combine all together into the inference engine, and then the output is going to be again converted from the fuzzy to a non-crisp state, that is the part of defuzzification. Okay, so let's begin with the first part. How will you defining the linguistic variable? Linguistic variable are the input and output variable in the form of a simple word. Okay, and also we'll take the condition, like for the temperature part, let's say T, we have this set: very cold, cold, warm, very warm and hot. These are the conditions that is will be provided in the linguistic term. Every member in this set is a linguistic term, and it can cover some portion of the overall temperature value. Out of the temperature, this is going to, if we have a set of temperature T, then this is going to be all part belonging to T. Okay, next step is to construct the member function. This member function table can be constructed in this way, where we are providing the voltage label and input temperature of that AC and the membership value, and we'll be taking down the fuzzification member function like n, very negative, minimum negative, this is small, maximum positive, like least positive. So these are the conditions that we are taking to construct the part of membership value. Okay, next we'll be approaching how to construct a knowledge based system. This is in the form of a matrix. Will be representing the room temperature versus the target temperature. What is the room temperature and how the agent is going to be identified with the target temperature, that value of the system is expected to provide. So this is the row matrix and this is the column matrix, that this is the column matrix, this is the row matrix that we are going to take. with all the conditions. One side we have the room temperature and one side we have the target temperature. So we are going to do the mapping. This is very cold, cold, warm, hot and very hot, and very cold, cold, warm and hot. So when this is going to be study out this table in such a manner. So when there is very cold and the target agent is also feeling very cold, then there will be no change in the fuzzification part. Yes, it is cold, so will not be switch on the AC. When it is cold, like very cold in the part, the agent has been feeling it is hot, so very cold ultimately will be changed in the part of a cold. If it is warm, then ultimately we are feeling as a heat is there, and it is hot in the sense heat is there, very hot in the sense heat is there. When it is cold and we are doing the comparison between the very cold, the agent is providing you the output as a cool statement. When there is a cold is there, and then target is also having the cold value, there will be no change. And similarly, all the diagonal elements that come in this matrix will be the no change, and by comparing each row to matrix, we can define the value. So next part, as the system has been studied, it is the part will be making the things, designing the knowledge base by using the if then else structure. So when we say if temperature equal to cold or very cold and target equal to warm, then the action has to be heat. Okay, this is the conditional statements that are been linguistic will be providing to the part of developing the intelligent system, as we are developing the inference rules over there, developing by the field of knowledge based development. The statement has been converted into the action format. So what is the condition? If temperature equal to hot or very hot and the target is also feeling warm, then the action has to be cool. The air condition automatically will provide you the room temperature into a cool environment. When the temperature is warm and target is warm, then there will be no changes will be the part will be considered whether you are switching on the AC or not. That depend upon the agent mechanism. Obtaining a fuzzy value. So after the fuzzification or providing the input to the knowledge based, developing the rule based, and all the rules have been taken down, now it is required to obtain a fuzzy value. The fuzzy set of operation, evaluation of the rules, and the operation of used by the method of or and AND, or are maximum and minimum respectively. Combine all the results and to evaluate the final result. This is going to be the result of fuzzy value. Then we will be providing the defuzzification to provide you the crisp output. Okay, so this method will be developing for performing the defuzzification. Defuzzification is then performed according to the membership function of the output variable. Whatever the output that we are getting, that is we come across with the value that is lies between 0 to 1, and when the member function is lying between the value of 0.5, we are getting an exact value that is going to be like. But when we do the such thing by using the traditional value, it is not going to be fruitful. Okay, so when we do the defuzzification, we come across this value is going to be maximum positive. Like when we say a value which is lies between 0.5 to 1, let's say 0.67. okay, this is also a value that is going to come across between the maximum positive part. Okay, and here we have make the wall here, that is will consider all the value that will be considered above 10 from 0 to 40 onwards, and we are taking the membership value or degree of membership value between 0 to 1, and we have given down and find out the exact value that is going to be lie with the fuzzifier set. It will be the value of maximum positive value where it is going to be lie down. Now what are the applications of the part of fuzzy logic? And mostly we come across with various part. Automobile systems are there, electronic goods are there, domestic goods are also there, environmental control systems are there. So these are some of the fuzzy logic applications. Automobile, gearbox, four-wheel steering, vehicle environment controlling. We come across with the electronic goods in the camera, in video cameras, television, photocopiers, the hi-fi systems. Domestic goods we come across with microwave, refrigerator, toaster. These are all the kitchen appliances where we are using. Environmental controls are still used, air conditioner, dryers, heaters, humidifier, humidifiers. This all part. What are the advantages and disadvantages of the fuzzy logic system? Mathematical concept of fuzzy reasoning is very simple, and also give you the accurate or exact value that we have been getting the solution for a complex problem. Easily can be modified by adding the defuzzification and the fuzzifier rules. Fuzzy logic system can be impacted and also distorted noise input, we will be not considering all the error and random signals can be eradicated. Fuzzy logic system is easy to construct and make a normal human being to understand also. And fuzzy logic is the solution to complex problem in the field of life, also including biological science, medicine development, making the human being in a good decision making system. Somewhere it is also having few disadvantages. No systematic approach of fuzzy designing is still yet been developed. Scientists are still making the research in the field of fuzzy logic and how it is going to be more fruitful in the field of artificial intelligence and science, and more in the part of information technology. And sometimes it makes confusion to the part of human being also, ununderstandable when it going to be a simple state in a complex world. Sometimes it creates a problem when we come across with the calibration issues that need to be having a good accurate value or accuracy to design the membership functions or the part of clearing the fuzzy set values. So students, this is for today's lecture. I think you go through with the notes once more. In most of the university exam you will come across with the long question for the fuzzy logic system. You will be designing the architecture and write all the parts of fuzzy logic system. In the next class we will come across with one more topic with fuzzy logic system, how we will be developing the member function, and with more number of examples. So for today, thank you so much for this video class.